Starting now. So, good afternoon, everybody. I'm Alex from the Leaders Award team, and welcome to this Leaders Award Home Learning online interview featuring Ellie Davies. Just before we get into kind of the interview today, I will run through what's going to happen during kind of the next hour or so. I should tell you that just because there are lots of people watching this event, we have muted everybody except for Ellie and I for the whole event, just so there's no kind of interruptions, distractions, or really loud feedback. The first part of the event will be Ellie's presentation, which shouldn't last more than 15 minutes or so. Please feel free to type in any questions at any point during this session. There is a Q&A facility. If you are watching on Zoom, it's at the bottom of your screen. If you want to type in your questions there, just throughout, even when Ellie's doing a presentation, if you can think of a question, just type it in, just so as soon as we get to the Q&A part of the interview, we can answer your questions as soon as we start that. This will be similar for those who are watching on Facebook and our Facebook stream as well. Please can you type your questions into the comment section on there. Then I will then relay the questions to Ellie for her to answer. Just before we get to Ellie, I'm just going to explain a little bit about what the Leaders Award, if you're an engineer, what would you do competition. So what is the Leaders Award competition? It is, the main aim of it is to inspire young people from ages, say 3 to 19, to look at the world around them and design solutions to a problem. This is a national competition that we run, and it's open a lot longer than it usually is to give you time to meet all of our engineering professionals, meet our professionals online, just like we're doing today with Ellie. Hopefully then you will be inspired and think of lots of ideas and start designing some of your own inventions. To help you do that, we've also got lots of available resources on our website. So if you've not already, at the end, you can register to our website to get all of our resources from there. Our suggestion for the competition is if you make it a weekly challenge, because it is Leaders Award Home Learning, you can do it a weekly challenge, interviewing all our engineering professionals that we've got on this week and in the coming weeks as well. And then you can look at different problems in the world you'd like to solve. Just before we all then head back to school, choose which of the ideas is the best to send in to us for your engineering professionals to then read. So this session is actually booked till 11:30. So without further ado, I'll now pass over to Ellie Davies, who is a chartered structural engineer who works for Borough Happold Engineering. So her job is to actually make buildings stand up using maths and science. I'm just going to pass over to Ellie. Hi, Ellie.
Hi, can you hear me?
Yes, perfect. I'm just going to stop sharing my screen, Ellie, and then you can share yours as well.
Okay. Just doing it.
That's fine. Don't worry about it.
Okay. Can you see?
Yeah, that's perfect. Thank you, Ellie.
Okay, cool. Oh, wait, we need the other one. I think. Let's put this one here. Got two screens, so I'm just confusing the matter. Can you see this? Like 2 slides. Right, let me share the other screen. I think this will work better. Got 2 screens on my computer just to confuse everyone. Okay.
Don't worry, I do the same sometimes.
Right.
Perfect.
There we go. Okay. So, hi, I'm Ellie. I'm a structural engineer at Borough Happold. So today I'm just going to talk to you a bit about, well, what does that actually mean, basically. So what is a structural engineer? And then I'll just run you through a bit of the different experiences I've had and a bit more of how you could get into it if it sounds interesting. So firstly, what is a structural engineer? Well, to understand what a structural engineer is, we first need to think about what a structure is. So if you look around you, everything that sort of resists gravity or the wind or any sort of force is a structure. So this can be from the ones that are more obvious, like buildings, they're a type of structure. But also things such as cars are a structure because they have to resist forces. They have to keep you in your seat when you're going along, no matter how fast you're going or if you change direction or if it's bumpy. Wind turbines are forces, so yes, they spin in the wind, but they have to make sure the tower doesn't fall over. And then you have more temporary structures like tents, which still have to do all the things a building do, but we can take them down afterwards. So everything on this slide is an example of a structure, but there's also all sorts more around you, even the chair you're sitting on. So what is structural engineering? Well, if we think of a building now, if we imagine a building is like a body, then what does each different professional do to help that body work? Well, an architect will think about what the body looks like. So, what is its form going to be? Is it going to be tall? Is it going to be small? Is it going to be big? Is it going to be small? What, where's it going to come from? What clothes is it going to be wearing? And where's everything going to be? Are the legs going to be in the right place, etc. The structural engineer makes sure the body can stand up. So we give it a skeleton. We design how many different pieces, strong pieces they need to be, which bits they're going to support, how they're going to support them. Then the mechanical engineer will look at the services, so the things running around the body. So looking at the blood vessels and what pumps the blood around the body, so the heart, and then the lungs to get its oxygen, etc. The electrical engineer will be looking at the nervous system, so how do we send signals to the different bits of the body so that they can do what we want them to do. And then the quantity surveyor will add that all up and check that it's not over budget. So they'll weigh the body and check that it weighs about what it should and it's not overweight. So if we look then at buildings, which is mainly what I look at when I design things, then actually a structural engineer is designing, in my sense of structural engineer, is designing basically everything around you, making sure it stands up. So if we make buildings stand up, what does the architect do? Well, if we try and think of the difference between an architect and a structural engineer, the architect is looking more at the kind of top left image. So they're thinking about, if we think, for example, about a school, they're thinking about how many classrooms are there needed, how many toilet blocks are needed, how many sports halls are needed, and where are they all going to go in relation to each other so that you can go around your school in an logical and an effective way. And when you want to get to sports hall, you can find it, and they haven't put different things in funny places. Whereas the structural engineer is thinking more about how is your school going to stand up? So how are we going to make sure that the second floor doesn't fall through the first floor? And how are we going to make sure when it's windy, the building doesn't just topple over? So we also look at other loads in some places. So if there's earthquakes in the area, we'll look at what forces earthquakes put on the building and how can we resist those too. So the architects think more about the layout and the feel of the building, but the structural engineer makes sure it stands up. So we also work with all sorts of other types of engineers. So we talked about electrical and mechanical engineer, but we also worked with geotechnical engineers who look at the soil and how strong it is, so we can know what we can put on it. Civil engineers who look at the drainage and also like the master plan of how the whole cities fit together. And there's all sorts of different ones that, if you're interested, you can look at, but we don't have time right now because we've only got 15 minutes. So a bit about my experience and how I got into my job today. So when I was at university, I was lucky enough that my fourth year research project, which takes about 6 months, was into a low-cost sustainable housing design for use in El Salvador. So two things to note is it needed to be low cost so that local people could afford it. And El Salvador has lots of earthquakes. So we needed to be able to resist earthquakes without the building falling down. So this is the rough design of the house. So specifically, I was looking at the walls. So the walls are made up of a timber frame and then bamboo spanning between the timber frame and then cement mortar placed on either side. So within the cement mortar, we actually put some wire mesh to help the cement stay on. And then we shake tested that to see if that worked when an earthquake happened. So we had to make this shake testing rig, which you can see in the middle, and then program the computer so that it would shake back and forth to represent a real life earthquake. And then we looked at what happened to the panels. So to test the panels, I had to make those as well. So it's a really good example of how engineering is a really hands-on approach to trying to solve a real life problem. So in this case, what we found was the wire mesh actually helped the mortar to stay on the panel. So when an earthquake happened and the panel shook, then the bamboo absorbed a lot of the energy because bamboo is very flexible. So that's good, so that the energy didn't go somewhere else we didn't want it to go. but when the bamboo is bouncing back and forth, actually released some of the mortar, which causes it to crack. But the important thing is, because the wire mesh was there, then that stopped the mortar completely falling off. So in real life, that would give the people in the house a chance to escape. And then once the earthquake had finished and it was safe to go back, they could knock off the cement mortar, and the frame of their house would still be standing up intact because the timber and the bamboo wasn't touched. And then they could reapply the mortar and go back to living there safely. So that was a really interesting introduction to real life engineering for me. I then started working at Bureau Happold. So we do lots of different types of engineering that are all to do with cities and buildings. So we've done lots of things that you've probably heard of, but you probably haven't heard of us. So that's quite typical of engineering. So one of the things we've done is what was originally the Millennium Dome, but is now the O2 Arena. The picture in the bottom left is the central court in the British Museum. So we did the roof over that. So that's interesting. Sometimes we work on new buildings, but often we work on existing buildings and how can we adapt them to new uses. And then the picture on the right is a new hotel in Macau, which is in China. And the interesting thing about that is the facade, so the outside of the building that you can see, is actually holding up the whole building. So then I went to Tanzania for a few months to design and build a sewerage system. So again, we take for granted in England, we have clean water and sanitation. We can just go to the bathroom, go to the loo, not even think twice about it. But in many countries, they don't have access to toilets, and if they do, they're often unclean and so unsafe. So the area, the informal settlement that we were working in, had pit latrines. So that's basically a toilet, and then it just your waste just goes into a hole in the ground. Now the problem is when it rains, and there is a rainy season there, the water just goes straight in because the pit latrine doesn't have a roof, and then the waste just overflows into the street. So then it's obviously unhygienic, and it can cause problems like cholera to spread very easily. So we looked at introducing a system that's been developed in Brazil and Pakistan, which is sewers like we have in England, but a lot smaller. So they can go in the narrow streets and they're a lot cheaper and easier to make. So we had to get involved with the local government to get permission and show them our designs and check they were safe. We had to get involved with the local community to persuade them that it was a good idea. And actually, in the long run, it's cheaper to install this sewage system because once it's there, it just runs. You don't have to keep paying somebody to empty your latrine or having the waste in the street. And then we got various charities and local universities to help us design and build it. So this is a really, really interesting, again, hands-on experience and just shows the power of how engineering can benefit people's lives. So another project when I started work that I spent 2 or 3 years on was the new Tottenham Stadium. So I was looking at the east and west stands and the steelwork. An interesting thing in stadia is, like most buildings, they obviously have to be strong enough to stand up and not move too much. But for stadium, you also have to think about what if there's a goal and all the fans stand up at once. They're effectively putting a dynamic force into the structure, so it might want to bounce, to vibrate. So how do we ensure the structure is stiff enough to prevent that happening? Because if it did, then people might panic. So then I think the pictures here just show how one of the things I love about structural engineering which is seeing your creations come to life. So the picture on the left is the computer model that we developed. So based on our designs and how big we think things need to be, we develop a computer model and drawings, and then we give them to the builder so that they can build it right. And then on the right, you can see what was built. So actually, if you take off the concrete terracing units, then underneath is what you see on the left. So very different scales, but it's pretty cool. So on the other end of the scale, another project I worked on was a large puppet. So it's about 12 meters high, and it's to go around Cornwall a few years ago to celebrate the anniversary of the Cornish mines becoming a UNESCO World Heritage Site. So completely different scale of project, but still need to think about the same things. So what forces are acting on the puppet, and how can we make sure that it's safe, especially with all those people watching? So in this case, when the wind acted, we wanted to make sure that the digger didn't turn over. But another important thing we have to think about is how can we communicate engineering ideas and design and checks to non-engineering people. So that was why I developed the picture on the left, which just shows the arrows show where forces are acting, so that the artist who was working on the project could get an idea of what was important and and how close it was to working or not working. Then a few years ago, I went to Rwanda to help to build a footbridge. So footbridges, like sanitation, are something, or just bridges in general, that we completely take for granted here. You probably go over a bridge without even thinking about it, to get across the river, to go to school, to go to shops, to go and visit your family or friends. But in many countries, actually, they don't have bridges because it's not so easy to just build a bridge. Especially if the river's wide or it floods in rainy season. And then people often risk their lives to get across, to go to school, to go to the market, to go to the hospital. So Bridges to Prosperity is a charity that helps communities to build bridges so that they can safely get across rivers. So that's what we're doing in Rwanda, working with local people. And then this is our finished bridge. So yeah, it's really interesting to see how engineering can be applied wherever you are in the world, but also to appreciate how lucky we are to live in the United Kingdom, where we have all this infrastructure, and yeah, I guess life is just day to day a lot easier. So if you're interested in engineering and you want to go further, there's different ways to get into it. First thing to do is try hard at school, which hopefully you're all doing. So primary school, secondary school, and then you might want to start an apprenticeship, or you might want to go and do A levels and then go to university. The good thing about engineering is because it's a practical subject, either's just as good. So I guess an apprenticeship gives you a bit more practical experience as you go along, and maybe the company that's supporting you might then help you with further training and education. But if you want to go straight to university, that's okay too. That's what I did. And then once you've built up enough experience, then you can go for chartership. So if you're chartered, it shows that you've reached a certain level, so people know that basically you can be trusted to design buildings. So yeah, that's everything. Are there any questions?
So we've actually got our, thank you, Ellie, for that. That was fantastic. Thank you for your presentation and going through everything that you've done in your career so far. We've got some questions that have come through on the Q&A already. So the first one is from Ronan. He's age 9. So what was your favourite subject when you were at school?
So when I was at school, so I liked, can you still see my screen, by the way? It's all right.
Yeah, if you stop your sharing your screen, and then it should come up with your webcam then, Ellie.
Oh, it's not letting me back into Zoom. Meeting controls, there we go.
Right. Yeah, there we go. If you just press stop share. Perfect.
Okay,
there
cool,
we go.
got it. Yeah, so I did like maths and science, but I didn't necessarily want to do something so practical. I also really enjoyed sport and still do. A bit harder at the moment, obviously, lockdown, to do as much sport. But then I also enjoyed art, and what I really like about engineering is it combines all of those things, and actually even sport when you're working on a stadium. But it's kind of using creativity and maths and science to solve problems and apply them to real life solutions. So rather than just thinking about a textbook, actually you can apply maths and physics to the real world. So yeah. Was
that quite exciting then, working on the Tottenham Stadium with you being so involved with sport as well?
Yeah, so that was actually one of the reasons I joined Bureau Happold. So I did a summer placement in their sports stadia team, and because stadia is so big, that engineering is really interesting as well. But then, yeah, it's quite cool to be able to work on a project when you're like it's in a field you're interested in as well. So yeah, you can definitely sort of go more towards a specific type of building if that's an area you're interested in.
Just to remind people, if you've got any questions, please post them into the Q&A section. Some have come through the chat as well. That's fine if you want to post them in the chat. And if you're on Facebook, if you can put it in the comments section as well. We've got one through from, I think, hopefully I'm saying this right, Amir. So what was your favourite country that you have visited?
So I don't know if I've got a favourite, but yeah, I have been really lucky. And that is one of the great things about engineering, to be able to work in so many different countries. I think in terms of engineering, Tanzania was probably the most, I guess, challenging and rewarding, because we were working in the local community with people who have so little, and actually being able to make a positive difference to their life. and because we were working on all stages of the project right from the start, so we had to work with the government to sort of persuade them that it was a good idea, then do the design and building it with the local community and university students, and then to be there at the sort of opening ceremony was it was worth all the hard work. So yeah.
We've got one from Lila. Do you need to be good at maths to do your job?
So you do need to have a certain level of maths to be able to calculate things. So we talked about how forces are applied to buildings, and then we've got to be able to resist the forces. So you do need to have an understanding of maths and physics to see how that works, but you don't need to be a mathematical genius. I think that's definitely a misconception, and there's different so with instructional engineering you can kind of focus on different things. So some people prefer sort of existing buildings, which is maybe more about assessing what's there already, and maybe is less of an exact science. And then some people actually start engineering and find they prefer more technical stuff. But then so everyone needs to do some technical stuff. That's the point of being an engineer. But some people, like, I guess, use more maths and become more technical, and then some people maybe focus on different sides, like maybe being more creative, or as you get more senior you can sort of start managing people, going to meetings, talking to clients, etc. So you maybe do less maths as you get more senior, but you need maths to start with to understand your job.
Lila's just said thank you for answering that, Ellie. So from Bryony we have, how many projects have you worked on?
I don't know exactly, like loads of different ones. So sometimes you can work on a project, like a big project like Tottenham. You can end up working on, I think I was on that for like 3 years, but you're not necessarily like full time on a project at once. So you can also, like, I've worked on a lot of smaller ones, like I'm working on a school at the moment which is being built in London, which is actually not that small. But then I've worked on like some student accommodation which was smaller, so maybe I worked on that for like a year, and then you might just spend a few months helping with some early stage design on something. So it's really lots of different options, but I've probably worked on like, I don't know, 30 or more in total.
So we've got one from Lisa. What is your favorite material to work with?
Well, I think favorite I guess most of my experience has been with steel. I think steel is good because it's a lot of it is recycled already, and it's easy to recycle. So the industry is increasingly thinking about how can we become more sustainable. And if you design steel buildings that can be sort of unbolted, so taken apart without using a wrecking ball, then you can reuse the pieces as well. And I guess it's also, so the main two materials that most things are built out of in the UK are steel and concrete. But steel, it's a lot easier to know exactly what the properties of the material is. So it's I guess there's less experience involved in working out how strong it is. It's more like you can do a test and work out how strong it is. Whereas because concrete is it's a composite material, so it's got lots of different ingredients in it. It's not as exact working out exactly how strong it is. But I think increasingly we're also trying to use timber more, so and timber products, so like CLT, which is panels made of timber, and that's definitely something I'd like to work more with, but haven't had that much experience with it so far.
And I know you've said lots of places that you've kind of visited, Ellie. Is there anywhere else that you would like to travel to with work, do you think?
I don't know. So another thing I actually didn't mention at all, but before lockdown, I was in Copenhagen for 4 or 5 months. So working for our office out there on a project that was on site in Sweden, which is actually a particle accelerator. Maybe I should have updated my thing. But again, that was a really cool opportunity to just go and live in another country for a few months. And Scandinavia is actually quite like England, but it's nice to go and experience different culture and live there for a bit. So that was good. I don't know. Maybe go back to Africa and work there, more like structures based at some point. Yeah.
Wow, fantastic! So that's another place you've been working as well, just before kind of lockdown happened as well. That's amazing. We've just got one through from Bryony. Did you always want to become an engineer?
No, so yeah, if you're at school and you're thinking, oh, like this sounds cool, but oh, I would never have thought of this, or like, oh, I haven't even started thinking about careers yet. Well, yeah, I didn't start thinking about it at all till probably had to choose my A levels, because if you want to go to university, for example, for engineering, they require maths and physics A levels, but for other subjects they might require other A levels. But generally, maths and science at university want maths A level at least. So I wanted to make sure I like picked the right options for what career I might want to do, but I didn't know which career this was at this point. And I actually thought about doing architecture, but then I went and did some work experience and realised it was like I preferred this sort of maths side. And so a family friend who was an architect suggested I might like engineering. And then I went and did a week's work experience in that, and yeah, really enjoyed it. So that was that. But yeah, when I didn't know, so that was 16 or something, I started thinking about it. But yeah, the good thing about engineering is because it's about problem solving, it's a really like in-demand degree or job. So if you start doing an apprenticeship or you start going to university and do engineering, but when you graduate or when you finish your apprenticeship, it doesn't mean you have to be an engineer for life, because you've developed some really good like logical thinking and problem solving. Actually, lots of other careers and industries might want you as well. So it's not like you have to choose your degree subject or your apprenticeship and then that's like it forever. There's definitely like lots of options to go in and out of different careers. So don't feel like you're choosing your A levels and you're committing yourself to anything for life.
So
yeah.
we've got one as well. How do you build structures that are unbolted?
Unbolted?
Yes.
Do you mean as in you can take them apart after? Or...
I think that's what they're going for. Yes.
Yeah. So it's more difficult because you have to think about deconstruction as opposed to just construction. But basically, in steel buildings, joints are either bolted together or welded together. So welding together, we try and avoid doing that on site because it involves like a hot person, it's a bit dangerous, and there's less controlled conditions on site. If you think somebody on a 5th floor trying to weld 2 pieces of steel together can be a bit dodgy. But often people prefer welding things together because it's a stronger connection. But the thing with welding something together is it's harder to get it apart again. So if you make a connection that just uses bolts, because a bolt is you just put it in and then you like screw up the other side, it's very easy to then go back and unscrew. And then once you've undone all the bolts, you can take it apart. But part of making sure that we can do that is making sure that when you start undoing things, the rest of the structure doesn't fall down. So it's, as well as being able to build it safely, you can deconstruct it safely. So yeah, it's not like super regularly done yet, but it's another thing in the industry needing to become more sustainable. It's yeah, another area that's being investigated more.
So we've got another one from Paul. What will you work on next?
Wow. Currently, yeah, like I said, I'm working on a school in London, which is on site. So most of the steel frames up, and that's due to open in October. Hopefully, lockdown doesn't delay that. So that's a secondary school, and then I'm also working on a stadium at the moment. And then the next project I'm doing is going to be residential buildings, which is in North London. So you can see like complete mix of uses, which yeah is one of the really interesting things. Get to work on such a variety of projects.
So sort of a question kind of away from engineering, Ellie. Kind of what do you do away from engineering to de-stress? I know you kind of mentioned sport before as well.
Yeah, so normally I love playing sports, so lockdown's like a bit limiting. But so at the moment, yeah, I run every other day, so that's my one allowed exercise a day, and then go for a walk the other day. So that's quite nice, just getting out of the house. But outside of lockdown, yeah, play lots of different sports. So summer at the moment it would be cricket, tennis, and touch rugby. I can't do anything right now, so it's a bit frustrating. And then yeah, like reading, seeing my friends, again not right now. So yeah, I'm sure like everyone else, my hobbies have been somewhat changed recently. But at least yeah, I can still read, I can still go running, talk to my friends over Zoom. But yeah, so mixed of things really.
Yes, I'm exactly the same. Can't do any of my sports at the moment, and it's really hard, but it's got to be done at the moment.
Yeah, and at least
with
you can still
everything.
go and do exercise once a day. So
Exactly, yeah. Running's I
keep
think the
fit.
main. Yeah, running's the main one I think at the moment for
Yeah.
me personally as well. So with these things that you do away to de-stress, do you think you've become then more creative when you're doing other hobbies?
Well, I think it's always good to when you become an engineer, you have a tendency to start looking at buildings around. If you're a structural engineer, buildings around you and how they stand up and everything. But also, you start looking at generally how things work. So I think it's always good to do other stuff than work, because you can look at a building that you might think is interesting, or a solution you might be able to apply to another job, or yeah, just getting away from work completely. I often found at school and university, often your best ideas or a solution to a problem you've been sitting at your desk struggling with for hours will just suddenly pop into your head, which is, yeah, it's amazing how the brain works. But yeah, so I think it's definitely important to get away, as well as just for your mental health, not working too much. And that's another good thing about engineering. It's definitely got a good work-life balance, or at least designing, if you're a design engineer generally.
Yeah, I think you were on about saying looking at buildings around you, and Lila's just come up with a really good question to kind of link to that. Do you have a favourite building in the UK that somebody else has built?
Well, I like lots of buildings, but I guess near to me, so I'm based in Bath, so the Clifton Suspension Bridge in Bristol, that's quite cool. Although it's a bit misleading, because it looks like it's got big stone towers, but that's actually it's steel underneath, but it's clad in stone, because the local planners didn't want it to look like it was steel. So that's, yeah, quite an interesting, looking at older buildings, you mix engineering and history and kind of understanding the social context of why the building was needed. And then it's just quite cool to go up there. You get a really good view down. And it's quite nice if you're in Bristol and you see it. It's fine looking over the city. So yeah, it's not a building, it's a bridge, but it's a structure.
So yes, it's a structure, like you said, as well. What's the biggest structure you've worked on from Bryony?
Well, the biggest one would be Tottenham, definitely. It's, I don't know, like 61,000 people or something can sit in it. And yeah, got to go to one of the test games, and yeah, it's just quite crazy sitting at the top. My sister was pretty scared because she's scared of heights, but it's a big building. It towers over all the terraced houses that are next to it.
Yes, it looks very, very, very big. But
Like a
really,
spaceship just landed.
yes, really nice, really nicely designed though. It looks incredible. Lila's actually said that she loves that bridge, and she's been over it as well. She went over
Oh,
it recently
good.
as well.
Next time you go, maybe have a look, see if you can figure out how it's standing up.
Yes, yes. So obviously the children and the families that are kind of watching today, we're wanting them to take part in our Leaders Award competition, which is all around engineering. Is there a theme that you can think of, Ellie, that could be good for the children to think about when they're doing this? I know we had Elaine last week, who was all about kind of renewable energy. So that's kind of one theme. Is there a theme at all that you can think of?
So what exactly do you have to come up with? Like an engineering idea, or?
Yes, so they have to look at a problem and think how to solve it, and then design kind of an invention around that
Yeah.
problem.
Well, I think in terms of, yeah, like our industry is also increasingly, sustainability is important. I guess thinking about if you come up with an idea, how can you make sure you're using either reusable materials or using maybe less material? So it's easy to throw a lot of material at a problem, and you can, if you put enough material there, you'll always get something to stand up. But how can you be a bit cleverer, and use less material but do the same job?
Yes, I'm going to put you on the spot a little bit here. Is there an invention, if you were taking part, say, in the Leaders Award, is there an
Yeah.
invention you could maybe you can think of that you would invent?
Well, if I could invent something, then I would do that rather than my job. But I'm not so good at thinking of completely wacky things. But
I'll give you time to think of that one if you want to have a little think of that. I think we've come on to some stuff about the Leaders Award there as well, and you've touched on to kind of the qualifications and some skills that you need for engineering. Do you know of any kind of non-academic skills that you need to be an engineer as well?
Yeah, well, there's loads of them, and I think that's a thing I didn't really appreciate till I started work. There's a whole to be good at your job. There's a whole raft of non-technical things that are at least as important, and the more senior you get, probably not more important, but so like communication. So any chance like you get to speak in front of other people, or like teamwork. So any sort of group projects can be annoying, but really really important. Actually, do replicate your job. And just like we were talking about, like creativity. So this award, looking at, I think fundamentally engineering is about like how do things work. So just that can like lots of engineers took that. I don't know, when you look back at when you're younger, different things. So some people liked making computers, some people liked fixing things. I know like every time we went to the beach, I would always try and dam a river. And when you're little, you're just doing it for fun. You're just interested and curious about how things work. But actually, it turns out like damming a river is exactly what civil engineers do, and structural engineering is just a type of civil engineering. So yeah, it's I think just being interested in everything probably just helps generally with engineering, and being able to work together and communicate your ideas to like important non-technical skills that are required. So yeah.
Fantastic, thank you for that. I'll just reiterate to some people, if you could put some questions into the Q&A section as well. We've gone through a lot there as well. And if you can put some in, if you're watching on Facebook as well, if you could put them into the comment section as well. We've just got one through there, Ellie. So do you use 3D models to help create and design the structures?
Yeah, so definitely. So we use so when we first start thinking about building, we'll just kind of try and think from the fundamental, well, I guess from physics really, how it'll work and how big things need to be. But then once we've worked out roughly how big we think things need to be, we'll often build a 3D analysis model, not necessarily of the whole building, but maybe of a specific section we're interested in, to check that like where we've assumed the forces are going seem to be right. And then, like I was saying, when we then start producing information to give to the builder so that they can build it right, every project nowadays pretty much requires a 3D model, and then we will cut sections and plans, etc., from that model so that we then have drawings we can give them as well. So it's all very much 3D in terms of virtually 3D in a computer. Architects make a lot of actual 3D models to think about how things fit together in details. We do have a 3D printer at work, so occasionally we do stuff like that. If we've got a complicated detail, we want to like communicate how it fits together, but probably not so much as architects do.
Is there kind of any advice you'd give to any kind of young engineers coming from either primary school or secondary school, or even going into the kind of further education?
I think like what I said before, just be interested. Obviously work hard at school, because you do
Yes.
need school qualifications to be able to be an engineer. But yeah, just be interested in how things work, and there's no wrong question. I think like I was asked a lot of questions when I was younger, like why, and it probably annoys your parents or whoever. But that's just being interested in how things work. Probably going to make you a good engineer. And actually, I know a lot of my friends from school, university, whatever. Maybe if they'd have known what engineering was, and how broad the opportunities are within it, and how it's not just about solving really complicated maths equations at all, would have really enjoyed it, but didn't really get the opportunity, because fundamentally I think everyone's got a natural curiosity about how things work, and engineering, in whatever field. Like obviously I'm more like involved in buildings and cities, but in mechanical engineering, electrical engineering, it's all just about how things work and how trying to make new things work. So I think just stay curious would be, in a cliche way, the best thing you can do.
Yes, I quite like that idea. You say no kind of question. You should always ask questions and everything like you said before. And I think that's quite important in our Leaders Award as well. It kind of, there's no restrictions on the inventions to design. I think you should go kind of as wild or as creative as you want to be, really, which is really important, I think, in engineering as well, isn't it? Is there another kind of field, another part of engineering that you'd kind of like to explore in the future?
Well, when I was at university, I actually did general engineering. So we did every type of engineering, and then we just had to pick one for final year. And so yeah, I actually really enjoyed fluid mechanics. So how planes can fly, basically. So yeah, whenever I'm at an airport, other than like when I'm like, oh, this is not good for climate change, um, it's amazing that like humans have developed things that can fly, and such heavy things that can fly. So I think that is really cool. And again, it still involves structures because wings naturally want to sort of flutter a bit. And how do you stop the plane falling apart under the high pressure in the air? So I think, yeah, planes quite interesting. And then we also did like information engineering. So like how does your phone get internet, basically? And that was really cool because again, it's something you completely take for granted, but some really clever person thought of, and then other clever people developed it, and now we all benefit from it. Especially again right now when we can't go and see our friends. Uh, so yeah, really enjoyed both of those.
We got another question here. So, what are the main forces you have to consider when creating buildings and bridges?
So gravity is always the main one because you can't escape gravity. Everything that has mass wants to be pulled towards the ground. And structural engineering is fundamentally about keeping it off the ground. And then wind as well, like everything involves wind, and it depends how big the building is, how much wind, and how stiff it is in certain places, what that wind's going to do. But then we also have to consider the temperature. So under temperature, things naturally want to expand and get bigger. But if we've made a really stiff building with lots of different stiff points, if it wants to get bigger, like the fact the building's so stiff kind of prevents it doing so. So then that locks in forces as well that we need to consider. So even though in England it doesn't seem like there's that much temperature change, even in England we have to actually design for quite a lot, especially in big buildings, because in total they want to expand more. And then if we're in an earthquake area, seismic is really important. Like that will often govern the design. So I haven't done much seismic design other than the particle accelerator I worked on in Sweden when I was in Copenhagen, because that contains nuclear material that had to be designed for seismic. But that's a whole different way of designing a building, which is again quite interesting. But I haven't done that much because we don't have to do it in the UK. So.
Brilliant, thank you. Thank you. We've got another one here. What is the most complicated structure you have worked on?
Not Tottenham as a whole, but Tottenham has so many different parts that are individually complicated. So it's got a lot of it's got a lot of transfer trusses. So that's when basically you want to create a big open space without columns in. So you have to kind of take the load from above and take it like around whatever you want to be free. So in the South Stand, I guess you might have seen on the news, whatever, but the pitch in NFL mode, the grass pitch can retract under the South Stand. But to be able to do that, you can't have any columns where the pitch needs to go. So it means there's a lot of trusses. So that creates a lot of complicated interfaces, and basically anywhere where you've got a lot of force and you're trying to transfer it from where it's acting somewhere else is always quite complicated. So yeah, and then I guess like the school I'm working on at the moment, it's quite interesting because it's got a proposed Crossrail route underneath it, and or HS3, one of them. So there's not a tunnel there right now, but there will be, and so then London Underground or Transport for London restrict how much load you can put on it. So then our whole design had to be about how do we avoid overloading the tunnel, because if we just do what we wanted to do, there'd be too much load on it. How do we spread the load out and get it away from the tunnel? So yeah, both quite interesting.
We've kind of touched on things that you do outside of engineering and everything as well, Ellie. Is there anything else other than an engineer that you would be if you weren't an engineer?
Well, when I was younger, I always thought, it'd be cool to be a sports person, but I'm obviously not good enough at anything, or maybe didn't take it seriously. I don't know. Seriously enough. But yeah, I don't know. I think psychology is quite interesting. which again, I guess shows that engineering is not just about maths. I think, yeah, in any job, just like thinking about why people make the decisions they do. And if there's a meeting with lots of people in it, like looking at the dynamics between different people. So yeah, I think that's quite interesting. But yeah, obviously something you need a lot of training in to actually do as a job.
Yes.
Can't just start doing it. But yeah.
Is there any kind of some children will be watching will want to know about, or parents will want to know about? Are there any like apprenticeship schemes at Borough Happold as well?
Yeah, so we do have apprentices. I think it's you come in at 18, not 16. I think you have to do A levels to come in, but we definitely take a few people each year and train them up. So initially they come in as technicians, so that's more people who do the drawing work and the model, like 3D modeling work. But then yeah, we like work pays them to go to college one day and gives them the time to go one day a week. And a few people who've done that have like worked up to eventually doing a degree in civil engineering as well. And yeah, doing really well. Like yeah, quite a few senior technicians at work started that way. So yeah, you definitely don't have to go to university if that's not something for you. So yeah, you avoid debt and you get a lot of hands-on practical experience from the start. So yeah, I think it just kind of depends which idea you prefer, I guess.
And something good for the parents as well, if they don't want to pay those uni fees as well. We've got one through there. So does different strengths of water, so say current, discharge and speed, impact how bridges are created?
Good question. So it definitely impacts the foundations and the piers. So the piers are the bits the bridge stands on, and then the beam is the bit that goes at the top. But the shape of the piers as well. So there's how fast the water flows and might flow in a flood, because obviously you don't want the bridge to just wash away in a flood. And that, yeah, so it affects how big the pier needs to be and the shape of it and the foundations, because that's going to want to rip the pier off, but how do we make sure it stays where it is? And then but yeah, it definitely does affect it. Oh yeah, and then the other thing I was going to say is, if you're in a shipping lane, you then also need to think about the potential of the ship hitting it as well as water. So yeah.
So I've given you a little bit of time to think of the invention that you would build, Ellie. Have you thought of anything at all?
No, because I was actually answering questions.
Yeah, I know. Is there anything around kind of your?
Think I've always I have thought of something I always wanted to do when I was younger, but like I always thought there should be a thing when I was younger. Basically, that like roads should have split levels, so like
Yeah.
either lorries can go underneath, so cars can go on top if the lorries are slowing people down, or like or like bikes can go on top, cars underneath, depending on safety. And then also, whenever everyone was in a queue on a road, I always thought that wouldn't it be more efficient if the cars all had like linking mechanisms, so that when everyone's just like crawling along at 10 miles an hour, everyone can somehow like link together and just like use their collective engine power so they can all go along at 10 miles an hour.
That's really good. That's obviously a problem that you see just saying when you're out driving about to your job, or if the children were driving to school, the parents are driving them to school. That's a really good problem that they could kind of see and think, oh, how could we kind of solve that problem, and what invention could come around that? So I think that's a really good idea as well, a good theme as well to go around kind of traffic and things as well. What we'll do now is, I think we'll end it there, Ellie, if that's okay.
Yeah.
Thank you. I just want to say a big thank you to you for answering all of those questions today. I think we have some really good questions and some really insightful questions. Yeah. So thank you everyone for sending in those questions on Zoom and on Facebook as well. Just before we finish, I just want to reiterate about the competition that we're running, the Leaders Award competition. So if you do want to go through with the competition, if you follow our website, www.leadersaward.com, there you will find our resources to help you and to help you come up with your ideas. And hopefully you can also find there as well all our schedule for all our other interviews that are coming up as well. I have also posted into the comment section and the chat sections our online survey. If you could please complete that online survey as well, just so we can give some feedback, not just to us, but to Ellie as well about the interview. I hope you've enjoyed it, Ellie. I hope everyone else has enjoyed it as well. Thank you, everyone, for being involved. And we'll leave it there. Thank you, Ellie. Bye, everyone.
Okay. Bye.